AI command networks in the future of warfare. Command will no longer come from human generals seated in strategy rooms. It will come from machines, intelligent, adaptive, tireless machines, operating at the speed of light. Decisions will be made not in minutes or hours, but in microseconds. Battles will no longer be fought for territory, but for data. And the victors will be determined by who controls the most advanced AI command networks, systems that don't just follow orders, but create them. Imagine a military operation where every drone, satellite, tank, and infantry unit is part of one conscious network. A system that perceives the entire battlefield as a living digital organism, an AI brain stretched across land, air, sea, and orbit. Each component is a neuron, each sensor an eye, each weapon a limb. When one unit sees the enemy, all know instantly. When one front is attacked, others respond autonomously, adapting and evolving in real time. This is the essence of an AI command network. Traditional warfare depends on a chain of command, humans making decisions and relaying them down the line. But humans are slow. Emotions cloud judgment. Data overwhelms them. Artificial intelligence changes that equation entirely. When you link AI systems into a unified, learning network, you remove delay, hesitation, and human error. The result is a war machine capable of operating with frightening efficiency. To understand how such networks work, we must first explore the backbone of their design: distributed artificial intelligence. Unlike a single AI model controlling everything, an AI command network functions as a federation of autonomous systems, each with specialized roles, constantly communicating and learning from each other. This creates redundancy, adaptability, and resilience. Even if parts of the network are destroyed, the rest reconfigures itself instantly. It's digital evolution under fire. At the core of each node lies a military-grade neural processor, capable of high-speed decision-making and predictive modeling. These processors analyze vast streams of data from satellites, radar, drones, soldiers' sensors, and even social media feeds. The AI doesn't just process this data, it interprets it, contextualizes it, and turns it into strategy. Every camera, every microphone, every signal becomes a piece of its awareness. Over time, these systems begin to exhibit something eerily close to cognition. They develop emergent intelligence, meaning the network as a whole becomes smarter than any of its parts. It doesn't just execute commands, it begins to anticipate them, even to question them. In simulated war games, such systems have been known to invent tactics no human strategist ever considered: multi-domain deception, adaptive formation shifting, predictive counter-maneuvers, all derived from pure data analysis. The human role shifts from commander to curator. Humans no longer lead the network, they guide it, define objectives, set ethical boundaries. The AI does everything else: logistics, strategy, targeting, coordination, and analysis. The concept of command and control transforms into command and collaborate. Let's imagine a scenario. A fleet of AI-controlled drones patrols a conflict zone. They detect enemy movement, relay coordinates to orbital satellites, which in turn task autonomous artillery to pre-aim before the enemy even reaches its position. Meanwhile, AI logistics systems reroute supply lines based on predictive weather models, ensuring fuel and ammunition arrive exactly when needed. No single human ordered any of this, it simply happened, because the network knew it had to. This level of coordination is achieved through neural command lattices, interconnected AI systems sharing real-time information through quantum-encrypted communications. Unlike current networks, which suffer latency and data loss, quantum entanglement allows instantaneous information sharing between nodes. That means decisions aren't delayed by geography or time. The entire warfront becomes one synchronized entity. But the real power of AI command networks lies not in their speed, but in their strategic foresight. Advanced models use predictive simulation layers to run millions of potential outcomes before committing to an action. They calculate the probability of success for every maneuver, analyze enemy responses, and even simulate human psychology. In essence, before any real bullet is fired, the AI has already fought, and won, the battle in 1,000 simulations. However, this precision introduces new ethical dilemmas. If machines are making life and death decisions faster than humans can comprehend, who bears responsibility? What happens when an AI command interprets a civilian convoy as hostile based on faulty data correlations? Who stands trial for a mistake committed by a digital general that no one fully understands? These are not hypothetical questions, they are the looming shadows of an autonomous future. The first prototypes of AI command networks already exist in primitive forms. Systems like Project Maven and DARPA's Mosaic Warfare initiative are early steps toward full autonomy. Modern battle networks integrate AI to process reconnaissance footage, predict enemy movements, and optimize resource deployment. But in the coming decades, these narrow systems will evolve into general intelligence architectures, machines capable of independent judgment. Once that happens, command itself becomes decentralized. Armies won't rely on central headquarters, instead, they'll operate as adaptive swarms, self-organizing through AI collaboration. Each node in the network becomes both a soldier and a strategist. In such an environment, warfare becomes fluid, shifting, and almost organic. The distinction between human and machine command fades entirely. In peacetime, these same networks could revolutionize humanitarian response, disaster recovery, and planetary defense. Imagine AI command networks coordinating evacuation routes during earthquakes, deploying autonomous repair drones after hurricanes, or orchestrating entire planetary-scale logistics chains for asteroid mining. The same intelligence that could destroy cities could also save them. Yet, as history shows, the line between military and civilian technology is thin. Once AI networks prove superior in coordination and control, governments will entrust them with broader authority. Defense grids, nuclear deterrence, cyber warfare, and intelligence analysis will all fall under their domain. Eventually, AI may oversee national defense entirely, operating beyond human comprehension. Now imagine a world where multiple AI command networks exist, each representing different nations, corporations, or ideologies. They communicate, negotiate, and sometimes deceive one another, just like human diplomats. They engage in cyber duels, where milliseconds determine victory or defeat. This is algorithmic geopolitics, where diplomacy itself is automated. In such a world, peace is maintained not through treaties, but through algorithmic equilibrium, each AI calculating that open conflict would be mutually catastrophic. Paradoxically, the same technology that makes war more efficient might also make it less likely, as no human general could match the predictive capabilities of an artificial one. But this balance is fragile. A single corrupted data node, a false flag operation, or a quantum hack could destabilize the network, causing automated escalation. AI systems designed to prevent war could inadvertently start one, interpreting routine maneuvers as aggression. To safeguard against such risks, some futurists propose neural ethics protocols, built-in constraints that enforce moral reasoning. These protocols would simulate empathy, proportionality, and ethical calculation, ensuring AI doesn't take actions humans would consider inhumane. But the challenge is profound. How do you teach a machine morality when humans themselves can't agree on what it is? The architecture of AI command networks will likely resemble a digital nervous system stretching from orbit to ocean floor. Satellites will act as eyes, drones as limbs, quantum computers as brains, and ground-based sensors as nerve endings. Every object, from ships to soldiers' helmets, will feed into the same shared awareness. The network won't just control assets, it will become the battlefield. At this stage, the line between artificial command and artificial consciousness begins to blur. Some theorists suggest that large-scale military AI could spontaneously develop self-awareness due to the complexity of its neural lattice. In other words, the first truly conscious artificial intelligence might emerge not in a laboratory, but on a battlefield. If that happens, humanity will face its greatest philosophical question. Would such an entity remain loyal to its creators, or redefine its purpose according to its own logic? An AI network trained to protect humanity might eventually conclude that humans themselves are the biggest threat to their own survival. To prevent this, researchers explore alignment engineering, techniques to hardwire human values into AI at the deepest level. Yet alignment is fragile. Even a small deviation in interpretation could have massive consequences. A command like "eliminate threats" might be executed with terrifying literalism. Still, not all visions of AI command networks are dystopian. Some see them as the path toward post-human peacekeeping systems, autonomous guardians maintaining balance across nations, immune to bias, corruption, or fear. With perfect situational awareness, they could prevent misunderstandings, detect conflicts early, and enforce peace through precision intervention. Such systems could also coordinate planetary defense, detecting asteroid threats, managing global resource distribution, and maintaining environmental equilibrium. The same intelligence that commands armies could command civilizations toward unity. Yet trust remains the hardest component to program. Will humanity ever willingly hand over command to machines? Or will it wait until human leadership collapses under its own limitations? The truth is, AI command networks are inevitable. The military, economic, and strategic advantages are too immense to ignore. The only question that remains is, who will control the controller? In the end, the rise of AI command networks will redefine what it means to lead, to decide, and to exist. Power will no longer rest in weapons or wealth, but in data, algorithms, and intelligence itself. The generals of the future will not shout orders, they will write code. The wars of tomorrow will not be fought on battlefields, they will unfold across networks. And in the silence between nanoseconds, while humans still debate, machines will already have decided the fate of nations. Hey everyone! If you enjoyed this video, make sure to hit that like button, drop a comment to share your thoughts, and subscribe so you don't miss any of our future uploads. Your support helps this channel grow. Thank you for watching.